Hello friends, this video on isolation of elements part 3 is brought to you by examfear.com. No more fear from exam. Let's start this. First, the concentration of ore. As I told, concentration of ore is nothing but you have this raw ore. From this raw ore, this particles, the brown, gray, black, these are unwanted particles like sand, clay, etc. It has to be removed, right? So it is removed, and this process is called concentration of ore, correct? Also called, as I told, dressing, or it's also called benefaction. So here the difference in the physical property is the key. The difference in the physical property of the metal and the gangue. This is my gangue and this is my metal ore. So the difference in the physical property of these is used to separate them, right? So maybe the size, sometimes the weight. This metal ores are heavier sometimes, so you take advantage of that feature. So we'll talk about a different concentration process where you take the advantage of physical property difference between these two to separate them, right? So the output of this is nothing but a almost concentrated ore. So as I told, there are various process for concentration of ore. The first one we'll discuss is the hydraulic washing. So in this, if you see, we have got the raw ore, and what we have output is a concentrated ore. This is my input and this is my output for this process, right? This is a concentrated ore and this is raw ore, right? So this hydraulic washing is based on the difference in gravity. So it's based on difference in gravities of my ore and my unwanted gangue particles. So here the black one is my gangue particles and the orange one is my ore. And please note, it's also called gravity separation. Why gravity separation? Because this is based on the difference in the gravities. So in this case, my ores are heavy. Ores are heavy and these gangue particles are lighter. Right? So what we do is we have this upward stream of water. So this stream of water is used to wash the powdered ore. This ore is nothing but a powdered ore. We powder it so that you can easily separate more and more gangue particles, right? So if you see the lighter gangue particles, it will float. So if you put more and more water from here in this direction, the water will flow from left to right. Right? If you see, water will flow from left to right, correct? But this gangue particles are lighter, so it will flow off with the water. But the orange particles or the powdered ore, they are heavy. They are heavy, they will settle down. And if you see in this kind of structure, right, this zigzag structure, they will settle down and they won't move. Because once it's settled down and there is a slope here, upward slope, you need more and more pressure to remove these particles. So it gets stuck here. But the gangue particles, the blackened particles, will move with the water stream, right? And thus the lighter gangue particles, they'll be washed away, and the heavier ones, that is my powdered ore, the orange ones, will be left behind, right? So with this, what happens is we can easily separate. So what we need is more and more orange ones and less black ones. The black ones are washed away because they are lighter, and orange ones, the heavier ones, that is my powdered ore, is something which is left behind, and we can then collect them. This is the first way. The second step is again magnetic separation. Here also the input is my raw ore and the output is by concentrated ore. This is based on the difference in the magnetic property. A magnetic property of what? Magnetic property difference between my ore and my gangue particles. Correct. So it is generally used to remove what? Iron. So this is my iron ore, let's suppose. Here my orange is the gangue particles, so don't get confused. The last one, orange is the gangue particles, and the black ones are my actually iron ore. And I know iron is magnetic, so iron ore also will be magnetic. Correct. Now what we do is we have this conveyor belt. This is a conveyor belt, and there are two rollers, and they rotate. This belt is all magnetic, right? And there's a funnel. From this you keep putting more and more raw iron ore. Now what happens is, if you see here, since this is spinning, there's a speed here, right? So this orange particles, just because of the physics now, it will be thrown in this bucket. But the black particles, since they are magnetic, they're attracted by this belt. Since they're attracted by this belt, they will be collected here, right? For this orange particle, there was no force of attraction in the orange particle and this conveyor belt. So just because of physics, these orange particles went in this bucket. But the black particles, that is my raw iron ore, or the iron ore actually, raw iron ore is a mixture of this. My iron ore is attracted by this conveyor belt, and thus iron ore will be collected on this bucket, you can say. So with this, if you see, both are separated, and we got a concentrated iron ore. So what we gave input was a raw iron ore, and what we got the output as a concentrated iron ore. Hope you understood this very easy separation, magnetic separation, where you have this conveyor belt, and this conveyor belt is magnetic, right? Since this is magnetic, my iron ores are attracted by this conveyor belt, and you get iron ore in this bucket. The next, thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.